Hello students. Dear students, today we are going to learn very important organic chemistry topic, that is oxygen containing compounds, alcohols, phenols and ethers. Today we are going to learn in detail about alcohols, their introduction, nomenclature, classification, preparation of alcohols, physical properties and chemical reactions of alcohols, including nucleophilic action of alcohols and electrophilic action of alcohols, where it reaction with metals, acidity of alcohols, esterification, reaction with halogen halide, PBr3 and dehydration mechanism, and methanol, ethanol importance in organic chemistry. What is alcohol in general? Yes students, so the compound which is attached with carbon with CO of single bond is known as alcohol. The hybridization is sp3 hybridization. If it is attached to methyl, it is known as methyl alcohol or methanol. The common name of this compound is methanol. How to nomenclate? If it is methane CH4, we will write methane. So just simply remove this E and add this O to the IUPAC nomenclature of methane, ethane, alkanes. From alkanes, remove E and add OL. It becomes alcohol. The suffix of OL becomes alcohol. And this is methanol. If you add CH3, CH2, OH, this is ethanol. The IUPAC nomenclature also is same for ethanol. This is common name. This is IUPAC name. Right? When it comes to propanol, CH3, CH2, CH2OH, the common name is N-propanol, whereas IUPAC name, it has to be given from here 1, 2, 3. Give the numbering from the alcohol group of carbon 1, 2, 3. So propane 1 all. If it is CH3, CH, CH3 and here it is attached, then what is the nomenclature? 1, 2, 3. It is isopropanol, common name IPA. When it comes to IUPAC nomenclature, propane 2 all. Similarly, if you take 4-member carbon CH3, CH2, CH2OH, it is N-butanol. OL students, butanol, it is butane 1 all. CH3, CH3, this is tertiary butanol, whereas 2-methyl propane 2 all. It is a tertiary alcohol. And when it comes to primary and secondary alcohol, the alcohol which is attached to the carbon having 2 hydrogens, or it is attached to only 1 carbon, this is 1 carbon, the hydroxy group is primary alcohol. And it is primary alcohol because the adjacent or alpha carbon which is attached to alcohol is attached to only 1 carbon, it is also primary alcohol. And this carbon, though it is attached to this side and this side, so now it is secondary alcohol. Isopropyl alcohol is a secondary alcohol. Then this is N-butanol is primary alcohol and this is secondary alcohol. Primary, secondary, tertiary alcohols nomenclature I am explaining students. So this is primary alcohol, and when it comes to this, since this carbon is attached to 1, 2, 3 carbons, so it is tertiary butanol. This is tertiary butanol or tertiary alcohol. Right? So all these compounds are having only one hydroxy group. Let us take one example. For example, CH2, CH2, OH and OH, ethylene glycol, and this is dihydroxy compound, right? 2 alcohols are there, ethane 1,2-diol. Yes students, so even you can get CH2, 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 this is triol. What is this? Glycerol. The common name is glycerol 1, 2, 3 triol. Yes students, so all these compounds having hydroxy group. This is also hydroxy group, dihydroxy, trihydroxy. More than trihydroxy, you can name it as tetrahydroxy or pentahydroxy. But more than that, you can say that polyhydroxy compounds. Right? So polyhydroxy compounds, for example, glucose, sucrose, carbohydrates will have polyhydroxy groups. Yes, students. So the compounds containing sp3 hybridization carbon, and very specific examples under this category is allylic alcohols. Allylic alcohols are the alcohols which are attached to CH double bond CH2. This carbon is sp3 hybridized carbon. However, the beta carbon is double bond carbon. So this allyl group is very specific. So the alcohols having allyl group are known as allylic alcohols. This is primary allyl alcohol. When it comes to CH2, or it can be CH or double bond CH and CH3, or it can be OH and hydrogen. This is secondary allyl alcohol. Double bond CH, C, R and R. It is tertiary alcohol of allylic alcohol. Though it is allylic alcohol, it is tertiary alcohol. And very specific examples under this is benzylic alcohols. Dear students, please don't confuse. Benzylic alcohols are sp3 hybridized alcohols, but these alcohols are at benzylic position. What is benzylic position? If you know the benzene structure, we have learned in previous class. So this is benzene. So this carbon is benzylic carbon. The carbon directly attached to benzene ring is known as benzylic carbon. If this carbon is having hydroxy group, it is known as benzyl alcohol or benzylic alcohol. If it is attached to remaining two positions are with hydrogen, then it is primary benzyl alcohol or benzylic alcohol. The common name of this is benzyl alcohol. If this compound is attached to other groups, for example, it can be aryl or alkyl groups, the remaining groups, this is OH and it is R group. It can be alkyl or aryl, that is methyl, ethyl or phenyl group, and it is remaining is hydrogen is same hydrogen, then it is secondary benzyl alcohol. Right? These are our nomenclature students. However, when it attached to this benzene ring OH and it is attached to other carbon containing compounds, either it can be methyl or it can be methyl or alkyl, any alkyl group or phenyl group. Yes, or another benzene ring also. Then it is known as tertiary alcohol of benzylic carbon. Then very specific compounds under this alcohols is vinylic alcohols. Usually vinylic alcohols are tautomers of aldehydes or ketones. For example, CH2, CH and OH. This is vinyl alcohol. This vinyl alcohol is nothing but, I can write like this. It is a tautomer of, it goes like this and it comes here, this hydrogen will be come here, and it is a tautomer of this CH3 double C single bond, hydrogen is here, acetaldehyde. Acetaldehyde tautomer is vinyl alcohol like this. So vinyl alcohols are also there. In this vinylic alcohols, the carbon attached to alcohol is, what is the hybridization here? sp2 hybridization. sp2 hybridization alcohol is there, right? So these vinylic alcohols are really in principle are not going to exist because they are nothing but tautomers of carbonyl compounds. Yes, students. However, so primary, secondary, tertiary alcohols, mono alcohols, dialcohols, trialcohols, tetra, poly, like that nomenclature you can write. And the specific examples, the hydroxy group attached to allylic position are known as allylic alcohols. At the same time, if the allylic carbon is a primary, then it is primary allyl alcohol. If it is secondary, then it is secondary allylic alcohol. So like this also you will get, students. So another way of writing this allyl alcohols. So allyl alcohol, this carbon is allyl carbon and it is attached to methyl group, and here it is tertiary. When it comes to benzylic alcohols, these are very specific examples where the benzylic carbon contains alcohol group. Yes, so benzylic alcohols, you may be asked to identify the alcohols which are primary, secondary, tertiary, or benzylic, or allylic, or vinylic. Yes, when the alcohol is attached to cyclic rings, for example, this is cyclohexane attached to alcohol, it can be written as cyclohexanol. And if it is like this, bromine is attached to cyclopentene and alcohol, then it is 2-methyl cyclopentanol. And before moving further, what is the hybridation? I have been explaining the hybridation in alcohols is sp3 hybridation, tetrahedral shape. Usually it should be 109 degrees 28 minutes, but in alcohols the bond angle is 108 because of this polarity nature. Preparation of alcohols. So the usual method is from alkenes. So alkenes are the compounds having double bond. For example, let us take ethylene. Upon hydrolysis in presence of acid, it is going to give ethanol. So this is ethanol we are going to get. So hydration of alkenes in presence of catalytic acid, we are going to get alcohols. We can prepare by acid catalyzed hydrolysis of alkenes. For example, if I take propene, this is CH3, CH double bond CH2, and do hydrolysis in presence of H plus. So in this case, two types of alcohols, primary and secondary alcohols are possible, students. That is what I want to show. Plus CH3, but only one is going to be formed. Why? Have you any answer? So in this case, is it going to form this OH or this? This is secondary, it is primary alcohol. Yes? So which is going to form major? Let us see. Is it going to form major? If it is so, then why? Let us see the mechanism. Dear students, secondary alcohols are going to be formed major when you take asymmetric alkene, because as per Markovnikov's rule, we are going to get this secondary alcohol. Let us see the mechanism so that you will understand. So the first step is protonation of alkene. So in presence of H+ ions, it will take up this water or it can take up this CH2. So it is going to take up this proton. Now we can expect two carbocations, CH3, CH, CH2 plus CH3, CH, CH2, and the two carbocations are, if this hydrogen adds to here, we are going to get this carbocation. This carbocation is nothing but secondary carbocation, and this hydrogen, if it adds to here, we are going to get primary carbocation. Yes, students? So the first step of this protonation of this alkene, if this hydrogen is added to the carbon which is primary and is going to give secondary carbocation, and in this case we are going to get primary carbocation. So we know when you compare the stability of carbocations, primary and secondary carbocation is more stable compared to this primary carbocation. So now what is going to happen? The OH H2O molecule which is there in the reaction mixture now adds to this secondary carbocation which is more stable carbocation to give. This is the second step where we are going to get CH2, and already hydrogen is here. Let me write for your understanding. Now this O, hydrogen is here. So this is oxonium ion we are going to get. Yes. So this oxonium ion, it is positively charged. So excess hydrogen is going out. This is removal of hydrogen. Is going to give, this bond has to be shown to oxide, to give alcohol. What is the alcohol we are going to get? This is secondary alcohol. We are going to get secondary alcohol. This is nothing but isopropyl alcohol. The mechanism is very simple. The first step is addition of proton, and this case you can expect two types of carbocations where it is secondary carbocation and this is primary carbocation. This secondary carbocation is more stable. So in this step we are going to get this secondary alcohol. As per the Markovnikov's rule, this is the nucleophile. It says that during the electrophilic addition of alkene, the incoming nucleophile adds to the carbon which is highly substituted. Incoming nucleophile adds to the carbon which is highly substituted with carbons, or you can say in other words, the incoming nucleophile adds to the carbon which is less substituted with hydrogen. Less hydrogens or more carbons. That is what Markovnikov's product can be obtained. So this is the usual method of preparation of alcohols where you will get Markovnikov's product. If I take only symmetric, this is ethylene. So no doubt whether I get this side CH2, OH and CH2 and hydrogen here. This is also ethanol and this is also ethanol. When it is symmetric or simple alkene, you are going to get only one product, but when it is unsymmetric, then you will get Markovnikov's product as single product. Then you will have a doubt. If I want to make this compound, that is N-propanol or primary alcohol, is there any method? Yes, students. So the method to make anti-Markovnikov's alcohol is via hydroboration followed by oxidation. Anti-Markovnikov's alcohol preparation from alkene by hydroboration followed by oxidation. Yes, students. Let us take same propene. Don't worry, students. You can attach any R group here, no doubt. So let me take same propene, and this time let us see what we are going to get. So the first step is diborane, hydrogen, BH2 taken twice. This is first step, and the second step is hydrolysis in presence of peroxide and base. I am going to get, so in previous example we obtained alcohol at this position. Now I am going to get CH3, CH2, CH2, and this time N-propanol I am going to get. N-propanol or propane 1-ol. Propane 1-ol. In previous example we obtained 2-ol, that is isopropanol. In this case we are going to get N-propanol. What is the mechanism? It is very simple, students. So diborane adds to this double bond. In this case this is boron. Boron is electron deficient atom, so it takes up this double bond. Yes, so it is syn addition, it is going to take place. Actually it is like this, it is going to form, right? Since the boron is electron deficient compound, boron is electron deficient, so it takes the electrons of this double bond to this. Yes, so now the intermediate, if you want to explain, so the first addition compound is going to form with boron, and here you are going to get cation. In principle it is not going to form. Even if it is going to form homolysis compound, here we are going to get this partial positive charge. This positive charge is taken up by this hydrogen. Now, so the syn addition, what is going to form? CH2. Now, this hydrogen is here and this is BH2. Yes. So BH2 has to be written as diborane. BH3 diborane. It exists as a diborane. You have learnt what diborane structure, right? So diborane, it adds to 1 mole of this alkene. Since it is also similar to this diborane, where if you think whole molecule has hydrogen, it is going to be diborane. So it further adds to another molecule of this CH3, CH double bond, CH2, where it is going to give, so the previous CH3, let me write this here, CH2, CH2, now boron is here, one hydrogen is here, and this time it is attached to here, CH2, CH, this is CH3. So this hydrogen is coming here, students. Yes? So another molecule, since it is having another hydrogen here, it adds to another mole of alkene, CH2, to give boron of this CH2 and CH2. Now when you add this hydrogen peroxide H2O2 in presence of sodium hydroxide, that is base, and water, you are going to get hydrolyze this compound. If you want the mechanism, it is going to attach to, for example, boron adds to peroxide OOH, and this is, if I write all this as one R group, R and R and R. So what is the position here? It is going to positive charge. So it comes here, and this R group is going to migrate to this oxygen, and this OH goes out. So it is going to give O, R, R and OH minus. In this case, so remaining two alkyl groups are going to be like this to give boron, OR, OR, OR. Now, when I do hydrolysis, I am going to get this RRR. This is alcohol. This side alcohol, and this boron is going to be, this hydroxy group is going to be with boron. So trihydroxyboron we are going to get. Yes, students, the important concept of this compound is anti-Markovnikov's addition of alcohol or hydroxy group to unsymmetric alkene. This is very, very important, students. So by simple hydration in catalytic method, we are going to get Markovnikov's product, whereas in presence of boron, diborane followed by peroxide, we are going to get anti-Markovnikov's addition product. Yes, so in principle, the first step is addition is taking place in Markovnikov's way only, but in this case the boron is going to be act as electrophile, whereas this hydride is coming as nucleophile. But in mechanistically, this is a syn addition, and it is a one-step addition where hydrogen and boron adds from the same side. Yes. So during the stereochemistry, it plays a role. The addition of boron plays a role. That is why I am explaining this. This is syn addition. Yes, students. Next. So reduction of carbonyl compounds. What are the usual carbonyl compounds? For example, aldehydes, ketones. These are carbonyl compounds. By what are the methods? I can do the reduction by simple catalytic hydrogenation using palladium on carbon, or platinum on carbon, or ranny nickel. Yes, friends, I can use any metal. Metal catalyzed, that is metal, palladium, platinum and ranny nickel. Don't you think that is other metals, right? Nickel, ranny nickel. And do the hydrogenation, I am going to get alcohol. This is alcohol, where hydrogen is going to add to this oxygen and this carbon to give primary alcohol. In this case, aldehydes are going to give primary alcohols. And if I take ketone and do same reduction, I am going to get secondary alcohol. Yes. So what are the reducing methods for the reduction of carbonyl compounds? Dear students, there are various methods. However, for your understanding, instead of this hydrogen and radical and all these things, sodium borohydride reduces carbonyl compounds, aldehydes and ketones to alcohols. So, if you have in your hand, yes, this is lithium aluminum hydride. This is a versatile reagent where it reduces carbonyl compounds, that is aldehydes and ketones. Yes, students. And another important reduction method of preparation of alcohols is reduction of carboxylic acids or esters. Yes, students. So carboxylic acid, let me write one carboxylic acid RCOOH and do the reduction. In this case, lithium aluminum hydride can reduce this carboxylic acid to RCOH, hydrogen and hydrogen. And this is first step. Yes, workup method is water hydrolysis. So you can prepare from carboxylic acid to alcohol by lithium aluminum hydride, whereas this sodium borohydride is not going to reduce carboxylic acids. It is very important and key point, students. For example, if I give this compound, try to answer this carbonyl here, O methyl ester, and if I reduce it with sodium borohydride, what is the product? And if I reduce it with lithium aluminum hydride, what is the compound? And if I reduce it with hydrogen, palladium carbon, what is the product? Yes, students. So this sodium borohydride chemoselectively reduces ketone group to give this alcohol, and whereas this ester group is intact. Ester is intact, in this case intact. So this selective reduction is known as chemoselective reduction of carbonyl compounds by sodium borohydride takes place, whereas ester group is intact. Do you know other name reaction or any name reaction where you can chemoselectively reduce only carbonyl compounds? Yes, I have explained it during name reactions. What is the name? Yes, if you know, the write down in chart box. Let me see. So the chemoselective reduction of carbonyl compounds reaction is MPV reduction, Meervin-Ponderoff-Wallrich reduction, where use of aluminium isopropoxide so reduces carbonyl compounds chemoselectively to alcohol. When it comes to lithium aluminum hydride, what is the product? Yes, carbonyl compound is going to be reduced. At the same time, this carbonyl compound also is going to be reduced to give this alcohol. Hydrogen and palladium carbon, just know what I said, carbonyl compounds can be reduced by hydrogenation in presence of palladium carbon. In similar manner, esters also can be reduced. So the product here also it is same. Preparation of alcohols from Grignard reaction. What is Grignard reagent? Alkyl or aryl magnesium halide is Grignard reagent. So what is the charge on this carbon or this R group? It is going to be carbanion or negative charge, and it is going to be positive charge, right? So how to make this alkyl magnesium halides? It is very simple. Where take alkyl halide or aryl halide, add magnesium in dry ether solvent, you are going to get magnesium alkyl or aryl magnesium halide. These are the Grignard reagents. Then how these Grignard reagents are going to give alcohols? Yes, students, when I treat this Grignard reagent with, for example, formaldehyde, this formaldehyde, yes, so formaldehyde upon reaction with methyl magnesium bromide in ether followed by hydrolysis. It is going to form this magnesium halide and hydrogen. It is here. How it is going to form? Just now what I say, it is going to be negatively charged and this is positively charged, right? So it comes here and this goes here. O minus is going to attach to magnesium halide and this is methyl group is going to come here. This RMGX complex upon hydrolysis I am going to get CH3 CH hydroxy group and this methyl and this is nothing but ethanol and this is primary alcohol. Ethanol can be prepared from formaldehyde using methyl magnesium bromide. So only this compound is going to give primary alcohol. In place of formaldehyde, if I use acetaldehyde CH3O, this is acetaldehyde and do the reaction with say methyl magnesium halide in ether followed by hydrolysis. I am going to get this is CH3, hydrogen is here and this methyl group is added to here and now magnesium halide and when I do the hydrolysis I am going to get CH3 CH. Now this CH3 is here. It is a secondary alcohol. If I use ketone, let me take acetone. This is ketone or the common name is acetone and if I use the same RMGX, this is methyl magnesium bromide in ethyl ether followed by hydrolysis OMGX and this methyl is here, this methyl is already here and newly this methyl here, this is going to like this and here also it is also going to like this. So this is a mechanism. It is going to add to here. Now upon hydrolysis this is going to give OH, CH3 and CH3. What is the alcohol here? Primary, secondary, tertiary. This is tertiary alcohol. All aldehydes other than formaldehyde are going to give secondary alcohols through Grignard reaction. All ketones are going to give tertiary alcohols in Grignard reaction. So physical properties, usually we learn about boiling point, melting point. Yes. So let me take boiling point. When it comes to boiling point, the general trend as molecular weight or carbon chain increases, boiling point is also increases. Yes. For example, methanol is 64 degrees centigrade, CH3 CH2OH. Ethanol is 78 degrees centigrade. Yes. So as the molecular weight of alcohol increases, boiling point also increases. Boiling point decreases as branching increases. For example, butanol CH3OH and tertiary butanol. So what is the boiling point? Which is going to have more boiling point? This is tertiary butanol and this is N-butanol. So because of branching, it is going to have less boiling point and this is more boiling point and less boiling point. Usually the boiling points of alcohols is more than, for example, hydrocarbons. So the compounds, if you take the same molecular weight containing compounds, alcohols boiling points are higher with respect to hydrocarbons, alkyl halides, ethers. Then why alcohols are having high boiling point? Because intermolecular hydrogen bonding. What is intermolecular hydrogen bonding? Let us take one alcohol ROH. Yes, so I can write HOR. I can write HOR. So these are all the alcohol molecules in a solution form. From each other can have intermolecular hydrogen bonding takes place. Because of this intermolecular hydrogen bonding, these are tightly close to each other and these are systematically packed, and the van der Waals forces also plays a role where the boiling point increases. So the boiling point of alcohols is more than these compounds because of intermolecular hydrogen bonding. And what about melting point? If the alcohol is solid, usually, so its melting point is going to be higher than the hydrocarbons and ethers. Yes, most of the alcohols are liquids. So that is why I have been explaining in terms of boiling point. So solubility, right? Alkyl halides are insoluble in water. When it comes to solubility of alcohols, so all of you know that alcohol can be mixed with water to give uniform solution, right? So miscible with water. Alcohol is miscible with water because alcohol is having OH and water molecule is also having OH. So this way it will have hydrogen bonding between alcohol and water molecules. Because of hydrogen bonding, alcohol is miscible with water, means uniform solution. You will get a uniform solution. It is not going to form any layer, right? So methanol is completely 100% miscible and ethanol is 100% miscible. There is no layer formation. When it comes to propanol, so these are all the way of writing, students. So methanol, MEOH is CH3OH, and ethanol, ETOH means CH3 CH2OH. This is ethyl, this is methyl, and propanol, CH3 CH2 CH2OH. Propanol is also 100% miscible. Yes, and when it comes to butanol, is immiscible or 15%, around 15% it is going to miscible, whereas about 85% it is going to form layer. So why it is going to take place? Because this long chain, this alkyl nature of this aliphatic chain, so as the chain increases, solubility also decreases with water, with respect to water. Alcohols are miscible with water and alcohols are miscible with organic compounds. Most of the organic compounds are miscible or soluble. For example, alcohol dissolves carbonyl compounds, dissolves alkanes, dissolves ketones, dissolves acids, dissolves aromatic compounds, aliphatic compounds, alkalides, even sugars also are soluble in alcohol solution. That is why it is one of the universal solutions or universal solvents of organic chemistry. So the most of the organic reactions were used to conduct in ethanol as a solvent, ethanol, or an organic solvent as ethanol. So because of its usual solubility nature, where it dissolves water and it dissolves organic compounds. Chemical reactions of alcohols can be broadly divided into two types, where it is going to act as nucleophile and electrophile. Yes, so this is alcohol, this is alcohol. Alcohol, when the bond is going to use its lone pair electrons, when it is going to react it with carbocation, it is going to act as nucleophile. Because of this lone pair of electrons on oxygen, alcohol is going to act as a nucleophile and going to react with electrophile. It is a neutral nucleophile. Then it is going to react with electrophile to give this R O hydrogen. I am writing down. This is remaining, say, R groups here. R closest proton to give R O C, say R group, R group, R group. So the overall reaction in this case, what is going to happen? So it is the bond between this oxygen and hydrogen is going to be detached, or breaking of oxygen and hydrogen is taking place. So the first criteria is cleavage of oxygen and hydrogen bond of alcohols is taking place. Yes, under this we are going to get some reactions where this hydrogen is going to be replaced or detached and going to be substituted with other electrophile or metals. And the second category is where the bond between carbon and oxygen. So let me write here carbon. So the bond between this carbon and oxygen is going to break. For example, if I add H plus with this donation, it is going to form oxonium ion. This oxonium ion loses water to give carbocation. This carbocation is electrophile. So alcohols can act as nucleophile as well as electrophile in reaction. So this electrophile nature comes by the detachment or the breaking of this or cleavage of carbon and oxygen bond is going to give electrophile. Yes friends, so the first criteria is cleavage of oxygen hydrogen bond of alcohols. So due to this reaction mechanism, it is going to break at this position. It is going to form salts with metals, reactions with metals to give important synthetic reagents. Let us take for example ethanol CH2OH and react with sodium metal. Let me take 2 moles here, 2 moles here. It is going to break CH3 2O sodium. Sodium ethoxide. This is organic base. This organic base is usually used in number of reactions. Yes, cleavage reaction. We have learned some named reactions. So this sodium ethoxide is used in named reactions or it is organic base. And this hydrogen, since we are using 2 moles, write down 2 plus hydrogen is going out. In place of sodium, you can use potassium also. Or for example, if I take CH3OH, hydrogen is here, CH3, 6 moles here, 2 moles of aluminium. I am going to get aluminium isopropoxide, which is used as reducing agent in organic chemistry for the reduction of carbonyl compounds in a named reaction where MPV reduction uses this aluminium isopropoxide. So it is going to exist as dimer plus 3 hydrogen, or you can write it like this also. Instead of dimer, you can write 2 moles of aluminium isopropoxide plus 3 moles of hydrogen. These 6 hydrogens are going out as 3 H2s. So this is how you can react alcohols with metals to give reagents. So this is sodium ethoxide and potassium ethoxide, and one of the common reagent tertiary butoxide, usually used organic base, sodium ethoxide, and all these oxides, alkoxides. So reaction of alcohols with metals gives alkoxides. Bases, organic bases can be used as organic bases, and this aluminium isopropoxide, though it is neutral, but however it is slightly basic, and it is used in MPV reduction for the reduction of carbonyl compounds to alcohols, chemoselective reduction of carbonyl compounds. Acidity of alcohols. Acidity usually described in pKa, right? The lower the pKa, low pKa, strong acid. High pKa value, the concept of pKa I have explained in that, and weak acid. So the overall acidity order of organic compounds is carboxylic acids are going to have pKa around 1 to 8, followed by phenols. Phenols are also acidic compounds. Phenols pKa value is about 8 to 12. When it comes to water, pKa value of water is 14, and the alcohols pKa is just above the 14, and usually it is 15 to 20. And another important class of compounds which are going to act as acids are alkynes, and this pKa is going to be above 20. Yes students, so alcohols are acidic. These are bronzed acids, What is Bronsted acid? Proton donors is an acid. So alcohol is a Bronsted acid because it can donate proton. For example, ROH plus conjugate base, it is going to form RO minus plus BH. Yes, it is going to donate this. This is base and it is going to act as an acid. However, alcohols are less acidic than water. So substituent effect on acidity of alcohols. Yes, students. So substituent effect when it comes to electron donating groups decreases the acidic strength. For example, if I write methanol CH2OH OH, so electron donating group, for example, methyl group, ethyl, methyl and alkyl groups are going to decrease the acidic strength. So among these homologous alcohols, methanol, ethanol, propanol, isopropanol, tertiary butanol, which is going to be more acidic? It is very important concept, and the question this has been asked in so many exams and so many times. Methanol is more acidic than ethanol. Ethanol is more acidic than propanol. Propanol is more acidic than isopropanol, and isopropanol is more acidic than tertiary butanol. Carbon attached to alcohol group, if it is attached to electron donating group, so this plus I affecting group, it is going to push the electron towards oxygen, where to act as an acid it should lose this proton and to form CH3O minus plus H plus, isn't it? So this negative charge, if it is attached to some electron withdrawing group, so this negative charge is going to be shared and it is going to be strong acid. So the electron donating groups decreases the acidic strength, whereas electron withdrawing group increases the acidity or acidic strength. For example, I can say nitro group is electron withdrawing group, or halogen substituted compounds. So nitro group increases the acidic strength. Let us take for example ethanol. So what is the pKa value of ethanol? It is about 15. Yes. So when you substitute this hydrogen CH2 and here nitro group and CH2OH, yes, 2-nitro ethanol, the pKa of this alcohol is about 8.3. So it is almost double acidic than ethanol. So this electron withdrawing group increases the acidity of alcohols. So tertiary are less acidic than secondary and primary are more acidic. These primary compounds are, this is primary and this is secondary and this is tertiary. So primary alcohols are more acidic and less acidic are tertiary alcohols. Yes, friends, because of this plus side affecting group. Esterification of alcohols with carboxylic acids. For example, acetic acid CH3 plus ethanol CH3 CH2 OH. So in presence of acid catalyst, it is going to lose water. So this is the bond, it is going to break, and here hydroxy group minus water, and to give CH3CO, this side I can write O2. What is this compound? This is ethyl acetate, common organic solvent we use in laboratory. Ethyl acetate can be prepared from acetic acid and ethanol, or acid with alcohol gives ester. This is ester. Yes, acid with alcohol gives ester, or I can write alcohol this side plus acid gives ester. In place of acid, I can take acid chloride. For example, CH3COCl, acetyl chloride, and same ethanol I am going to get same ester. Yes, So I can use acid or acetyl chloride, or I can use acetic anhydride or anhydrides. So this anhydride, whatever may be the anhydride, or acid chlorides or acetic anhydrides or some other anhydrides, also gives esters. Yes, students. So in presence of this case, I can use pyridine for the take up of the HCl. Whatever comes out, this chlorine is going to come out as HCl of this alcohol, and this chlorine, this hydrogen and chlorine is going to come out as HCl, and this HCl is going to break this ester. So to stop this breakage or spoiling, so we use pyridine, where this pyridine is going to act as base and it is going to form hydrogen chloride salt with HCl. So when you use this acetyl chloride for the esterification, use pyridine as a catalyst or to quench the HCl gas which is going to be released in the reaction mixture. Or if you are using this acetic anhydride, no doubt it is going to come out as acetic acid. This acid is going to come out as acetic acid, but this acetic acid, so this hydrogen is going to form this acetic acid, and this acetic acid is not going to disturb your ester. So esterification can be done using alcohols where this bond is going to be disturbed. Dear students, this bond is going to, OH bond is going to be disturbed. Yes, let me explain. CH3 CH2OH plus same CH3 CH2 COOH. Yes, if this oxygen is labeled with isotope, that is O18. So what is the molecular weight of oxygen? Isotope of oxygen is 18. O18 is isotope of oxygen. So if I use O oxygen, so what is the compound I am going to get? CH3 COO CH2 CH3. So is this oxygen is going to come into this ester? Is it this same oxygen or this oxygen? So it is observed that this is the oxygen which is coming here, right? So this oxygen is going out as water with this hydrogen. Yes, students. So that is why it is said that the esterification is taking place by the cleavage of oxygen and hydrogen bond. Yes, students. Dear students, please subscribe my channel BNS Academy if you are not yet subscribed. Don't forget to click on like button and bell button. Dear students, if you have any doubts or queries related to organic chemistry or chemistry, please post in comments box so that I can answer your queries even during today or in this lecture or later. Whenever you are watching this video, if you have any question, please write in chat box. Yes, students, let us see the reactions of alcohols where the bond of carbon and oxygen takes place. So what are the reactions? Usually you come across reaction with hydrogen halide. Yes, students, the important reaction or the distinguishing test is Lucas reagent, concentrated HCl plus zinc chloride. Aqueous solution is known as Lucas reagent. This Lucas reagent is used for distinguishing tertiary alcohols. For example, this is CH3. Tertiary alcohol or tertiary butanol, upon reacting with this in presence of Lucas reagent, this is, I will write LR, Lucas reagent, LR, right? So this tertiary alcohol is soluble in aqueous solution of HCl and zinc chloride, and this tertiary alcohol, the moment we add to this Lucas reagent at room temperature itself, tertiary alcohols at room temperature itself are going to form this halide, tertiary butyl chloride plus zinc hydroxide. So it is going to form tertiary butyl chloride. This tertiary butyl chloride is insoluble. So tertiary alcohols, as soon as we add to Lucas reagent, is going to form precipitate type or hazy turbid precipitate or hazy solution we are going to get when we add tertiary alcohols. When it comes to secondary alcohols, it requires, yes, these are soluble. These are also going to make alkyl halides, but it is slow and it requires warming. Warming temperature is required to form this. So it is immediate, tertiary is immediate, secondary is slow, right? So this is insoluble. When it comes to primary alcohols, CH3, CH2, CH2, CH2OH and glucose reagent, primary alcohols requires heating. This is soluble and this is insoluble. Turbid solution it will form, but it required insoluble or hazy turbid solution it is going to form, but after heating, where this is also insoluble. So glucose test of alcohols is used for distinguishing primary, secondary, tertiary alcohols. So this concept utilizes the solubility of these alkyl halides, where tertiary alkyl halides are going to give very easily from tertiary alcohols, and whereas secondary halides are going to be formed from secondary alcohols at little temperature. When it comes to primary alcohols, it is not going to take place that easily to form chlorides, right? So because of this test, you can distinguish in a lab where if a unknown compound is given to you, whether it is having primary, secondary and tertiary alcohols, you can distinguish using glucose test, glucose reagent, right? So why it is very easily forming? It easily loses OH, and the carbocation which is going to be formed as an intermediate is going to be stable, so it easily forms carbocation. That carbocation takes up chlorine which is available in the reagent to give halogen. Yes, whereas primary carbocation is less stable, tertiary is more stable, so the carbocation which is formed during the reaction is going to be the rate determining step. Next, alcohols reacting with PBr3 or PX3, it is going to form alkyl halides. This is bromine. So 3 here and S3PO3 here, it is going to be alkyl halides are going to be 3. In place of this PCl5 you are going to get R chlorine. If I use a red phosphorus in presence of halogen, X can be bromine, iodine, it is going to give RX. The usual method of halogen preparation from alcohol is H plus thionyl chloride, it is going to give R, this chlorine. Yes students, so this is how you can do the halogen preparation from alcohols by reacting with PBr3 or thionyl chloride or red phosphorus or bromine and iodine. This is how it is going to form halides by the cleavage of this carbon and oxygen bond. Next, so dehydration of alcohols is nothing but removal of water from alcohols. So for example, if I take OH and hydrogen upon heating with acid, I am going to get alkene plus, and it is going out as water minus water. For example, let us write ethanol here. This is ethanol. It requires concentrated sulfuric acid. So what is the percentage concentrated? It is about 98% pure. Yes. So 98% concentrated sulfuric acid, about 170 degrees centigrade. It is going to lose this as water and it is going to give this alkene. Let us take another example where if this alcohol is secondary alcohol, this isopropanol, it requires mild conditions where I can use 85% of H3PO4. It is an acid and it is also going to give propene. CS bond H2 plus it is going to lose, here I can write hydrogen and it is going out as water, and this case it is going out as water. Tertiary alcohol, CH2 hydrogen, here I can write CH3. So it requires same acid S3PO4, it is mild acid and 85 degrees centigrade. So the temperature below the boiling of water temperature. So it is going to lose this water and going to give this alkene. That means overall dehydration order of tertiary. This is tertiary alcohol. This is secondary alcohol. This is primary alcohol. Which alcohol is undergoing dehydration very easily? Tertiary is going very easily compared to secondary, compared to primary. Yes. So let me write here methyl here. What is there? Methyl, and here also methyl. Three steps. The first step is protonation of alcohol. CS3, here hydrogen and hydrogen. Yes. So CS3, hydrogen, hydrogen. And this alcohol, since we are using acid, it is going to protonate. This lone pair of electrons which are there on oxygen is going to be protonated to give this already present hydrogen is here, and now new hydrogen has come to give oxonium ion, and this is the step 1 where formation of oxonium ion takes place. Now the slowest step, step 2 is slow step, is nothing but rate determining step, is losing of water molecule, where it is take up this oxygen and carbon bond is going to be cleaved to give minus water. Yes, it is going out as water to give carbocation. C, H and H, 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 CS3 is here. Now what is the carbon nature here? Carbocation, formation of carbocation. Yes, though it is slowest step, but the moment it forms, it immediately, it is unstable, it immediately takes up this proton. Step 3 is removal of proton. So this proton is going out to give CS3, CH, and this is gone, double bond C, and these two hydrogens are here. Yes, so this is the product. So the overall reaction is minus water here, and this H plus ion which is coming here, it is going to recycle here, and this is going to act as H plus ion in the first step. Oxidation of alcohols. So in principle, what is the oxidation? Leoger, we have learned Leoger. So Leoger is nothing but letting of electrons is oxidation, or addition of oxygen is oxidation, or removal of hydrogen is oxidation. Removal of hydrogen. In this case, we are going to remove one hydrogen from here and another hydrogen from carbon. Yes, it is going out as hydrogen, minus hydrogen. So removal of molecular hydrogen from alcohol is known as oxidation of alcohols. This is primary alcohol. So minus, I can write here hydrogen. It is going to give aldehyde. This is aldehyde. Primary alcohol gives aldehydes, whereas secondary alcohol, if it is OH and R prime at this side R, yes, so it is going to lose oxidation, minus hydrogen. So this and this hydrogen, minus hydrogen, it is going to give, or this is ketone. Primary is going to give aldehydes, secondary is going to give ketones, whereas if I take tertiary alcohols, is it going to give alcohols on oxidation? No. Oxidation conditions, tertiary alcohols, no oxidation reaction. Yes, students. So what are the common reagents available for the oxidation of alcohols? So oxidation of alcohols, right? R can be hydrogen, or alkyl, or R group. Yes. So oxidation of alcohols can be done used by, so the common reagents are chromium 6 complexes. Chromium reagents are chromium 6 compounds. So the chromium 6 compounds I can use directly chromium trioxide in water and sulfuric acid. If I use chromium trioxide in water, since this sulfuric acid is very strong, I can use acetic acid, sulfuric acid, and in place of water, if I use acetone, it is known as Jones reagent. So some compounds may be acidic sensitive. To overcome that problem, there is a reagent, chromium trioxide, pyridine plus HCl, pyridinium chlorochromate is known as Sarett reagent. Yes, or if I use chromium trioxide and in pyridine and in dichloromethane, it is known as Collins reagent. These names are very important, students. Collins reagent. Yes. So if I use, and this is one type of reagents, and the second type of reagents is MnO2. Yes, MnO2 oxidizes alcohols to aldehydes and ketones. Usually MnO2 best works with allyl and benzylic alcohols, right? And the second category of reagents where I can use oxidizing agents for the oxidation of alcohols to carbonyl compounds is DMSO plus DCC. What is DCC? Dicyclohexyl carbodiimide, and this is known as Moffet reagent. Moffet reagent. And in this category, DMSO, if I use oxalyl chloride plus some base, let us take triethylamine, then oxidation. Yes, students. Next, and I can use DMSO in acetic acid also, acetic anhydride. And the other reagent is silver carbonate. Silver carbonate as oxidizing agent plus phthalate. And very important and chemoselective reaction is opener oxidation. Yes, it is a reversal of MPB reduction. Opener oxidation uses aluminium isopropoxide or aluminium tertiary butoxide. So this aluminium tertiary butoxide oxidizes alcohols to carbonyl compounds. It is chemoselective. These reactions may stop at carbonyl compound if we use strong acids instead of chromium trioxide, and if I use KMnO4, what is going to happen? So over oxidation, what is going to happen? These carbonyl compounds, if this is H, over oxidation takes place to give acids. Yes, oxidation is removal of hydrogen, and this is over oxidation is addition of oxygen is taking place, right? To give over oxidation products, carbonyl compounds to carboxylic acids. So another way of preparation of this oxidation is passing of alcohol vapors on copper. For example, RCH2OH on copper, red hot copper at 300 degrees centigrade. It is going to remove this hydrogen to give aldehyde. So primary alcohols are going to give aldehydes. If I take secondary alcohol in presence of copper at 300 degrees centigrade, it is going to give ketones. However, under same conditions, under similar conditions, if I use tertiary alcohols, since it is not going to undergo oxidation, it undergoes elimination reaction where it is going to form CH2. For example, here if it is something there, R and R prime. So alkene it is going to form. So primary alcohols upon passing on red hot tube is going to give aldehydes, and secondary alcohols is going to give ketones. Tertiary alcohols are going to give alkenes. Yes, students, methanol. How to write methanol? METHANOL. So what is methanol? Chemical formula CH3OH, and this common name is wood spirit. So it is obtained by wood destructive distillation of wood. We are going to get methanol, CH3OH. So that is why it is known as wood spirit. However, reduction of carbon monoxide with hydrogen in presence of zinc oxide and chromium 3 oxide at about 200 to 300 atmosphere means pressure, and about 300 to 400 degrees centigrades, it is going to give methanol, CH3OH. So this methanol is nothing but colorless solution, colorless liquid. And what is the boiling point? Boiling point is 64 degrees centigrades. So usually we use methanol as washing solvent in organic synthetic lab and as a reaction solvent in organic synthesis. Yes. So this methanol is widely used in paint industry as varnishes and all. The important thing is this methanol, if it is taken by human beings, it is going to be oxidized in the stomach or in intestines into formic acid, and this formic acid is highly poisonous and it is going to result blindness, and this blindness, sometimes excess methanol is taken, even it may lead to death also. First it forms formaldehyde, then over oxidation formic acid. So this formaldehyde and formic acid are highly poisonous. Ethanol is widely used for the preparation of formaldehyde. So ethanol, CH3 CH2OH. This ethanol is traditionally prepared by fermentation of molasses or sugars. So during sugar extraction, or sugar cane or grapes will have sugars, right? These sugars, what is the sugar formula? Sugar is C12H22O11. Upon treating with invertase as an enzyme, this sugar is going to be converted into glucose, C6H12O6 plus C6H12O6. So glucose is CHO, CH2OH, OH. This is hydrogen, and hydrogen. And when it comes to this carbonyl compound, and this is CH2OH, right? So this is aldehyde and this is ketone. So it is going to break sugar into glucose, and this is fructose. Yes, students. So fructose is a ketose and glucose is an aldehyde. This is how sugar is going to break into glucose and fructose by using invertase enzyme. This mixture, upon treatment with gymase, the enzyme from yeast, it converts as glucose as well as fructose into 2C2H5OH plus 2C2O2, 2CO2, right? So each glucose or fructose, it is going to be converted into ethanol, and this is carbon dioxide goes out. And this reaction must be done in anaerobic condition. If it allows oxygen, this alcohol is going to be oxidized to acetic acid, CH. This alcohol is going to be oxidized into acetic acid, and this acetic acid spoils the gymase enzyme action. At the same time, this acetic acid is going to disturb or destroy this alcohol where it is not consumable. So this gymase reaction is going to be done under anaerobic conditions. This is one of the key points under this reaction. However, nowadays most of the alcohol is prepared from this hydration of alkene, right? Just now we have learned hydrolysis of alkene in presence of H plus, it is going to give CH2H and CH2OH. Ethanol is going to be prepared from ethylene gas. Ethylene gas is going to give ethanol. So this is a commercial method. Nowadays we are using commercial or synthetic method, and in this way we are going to get pure alcohol devoid of water. So in this case there will be no water, whereas in this case you will have a lot of water. Most of the organic reactions requires 100% alcohol or 100% ethanol. This 100% ethanol is known as absolute alcohol. Yes, students, or absolute alcohol is also known as rectified spirit. So rectified spirit is used for surgical method and absolute alcohol is used in organic chemistry. So however, consumption of absolute alcohol or rectified spirit is highly poisonous because it is acidic. It is going to have effect on central nervous system and other body organs where it is going to act as destructive agent. So to avoid consumption of this alcohol, yes, so the usual ethanol what people consume is about 35% alcohol is going to be used with water, right? So absolute alcohol is 100% alcohol is not consumable. So to avoid the consumption of alcohol during the transportation, this alcohol which is coming from this fermentation method will be mixed up with copper sulfate where it gives some color, and to give foul smell pyridine will be added. So this alcohol or ethanol mixed up with copper sulfate and pyridine is known as denatured alcohol. Ethanol is a colorless liquid and its boiling point is 78 degrees centigrade. Yes. So what are the uses? Usually organic solvent. It is used in most of the organic reactions. It is a common reaction solvent of organic chemistry. It is used as organic solvent and it is used in organic varnishes, preparation of paints, and most of the cases this ethanol is used as a synthon, means the starting material for the construction of various compounds. Right students? So this is how ethanol is very important. Dear students, I hope you enjoyed this alcohols chapter. During watching this video, if you have any doubts or any queries regarding this alcohol chapter, or even if you have any doubt regarding organic chemistry, please write in comments box. And don't forget to click on like button and bell button. Dear students, please subscribe my channel Venus Academy if you are not yet subscribed, and don't forget to click on like button and bell button. We will meet again with a new topic. Most probably the next topic of this alcohols is phenols. We are going to meet with phenols chapter. Till then, bye. Thank you. Sayonara. Arigatou gozaimasu.